Earlier we looked at faults that were on the dip. Now we're going to look at faults that move along the strike. So with dip slip faults, we're mostly looking at compression and tension, but that leaves out shear. So shear stress, we have motion that is parallel but in opposite directions. Now if we looked at, so here's our fault here, if we were to slice through several slices of a fault, if the fault moves parallel but in opposite directions and we cut it, it wouldn't look any different. We would not be able to see any motion whatsoever. So we would have no idea that the fault perhaps was even there, unless we could see something on the side here that would indicate motion, some scratches or something on that fault trace. So in order to see motion on a strike slip fault, we can't look at the cross section. We have to look at the top, the map view, the planar view. So here is the top surface. So we can imagine this is the ground, and I've got a little stream here, and I don't have black for road top, but so I put a road in as white. So if the fault moves, then if it moves this way, notice that the stream and the road are both offset. Can also move the other direction, and the stream and the road are still offset. Now we don't talk about hanging walls and footwalls here because there is essentially no hanging and no footwall. We're more concerned with motion left or right. Now to calculate that, so if we are standing over on this side of the fault block, we are going to figure out which direction this side moved. So if it moved to, so if we're standing here and this side, we look at this moved, if it moves that direction towards you in the camera there, then that would be a left lateral, because to me, standing on this block, it moved to my left. And if it moves this way, away from the camera, then that would be moving to my right, which would then be right lateral. So, standing on this side, motion like this, that's what left lateral looks like. Again, look from this side, looking across to see how this one moved. If it moves this way, that would be right lateral. So, left lateral, right lateral. Now this is how the San Andreas is. So, little problem here. I'm going to flip it here because we don't have roads to match up. So Los Angeles is on the Pacific plate over here, and San Francisco is on the North American plate over here. In 17 million years, San Francisco and Los Angeles will be neighbors. So, is that motion right lateral or left lateral? Watch again. Right lateral or left lateral? If you said right lateral, you're correct. So, the San Andreas is a right lateral fault where the Pacific plate is moving relatively north and the North American plate is moving relatively south to the two, and eventually, assuming nothing changes, Los Angeles and San Francisco will be neighbors in 17 million years.